So we're going to talk about systems of equations. A system of equations is simply a whole bunch of equations that are graphed on the same coordinate plane. For our intents and purposes, we're going to keep it to two equations, and they're both going to be linear, so they're both going to be lines. So if I draw this line and this line, how can I make these two lines intersect? Well, they're going to share one point. So this one has an infinite number of points, and this one has an infinite number of points, but they share this one point, which means we would say that this is one solution, or we could say that it's consistent. Okay, we're consistently trying to find the solution. And then that solution would be an xy coordinate. Okay, so it's got one solution or it's consistent with one solution, but regardless, either way, it's got an xy coordinate. All right, so another way that two lines can interact is if they are parallel. So if my solution is going to be the points that they have in common, well, these don't have any points in common. So this is going to be inconsistent because we are consistently trying to find an answer, and we can't find them here. So this is inconsistent, and there is no solution. So this is not zero, this is the empty set. There is no solution that will make this work because they don't share any points. The last one is be a line on top of itself. So if I were to draw this line around and right smack, visually on the graph, you can't see that there's two lines. But algebraically with equations, you would see that there's two equations. They have an infinite number of solutions. So that would be consistent because you're consistently trying to find answers. But it has an infinite number of solutions, and I'm not giving you any of those. Okay, so you're either going to find one solution or you're going to find no solutions. These aren't hard, but Hawks makes it hard. And so we're just going to keep it as we're either going to find the one point that are So we've got a few different ways to handle this. We can do elimination, which happens to be my favorite, because we get to kill variables. Or we can do substitution. And unless it's absolutely perfectly set up for substitution, I'm not going to do substitution because it just means we've got to find one variable in terms of another. So like y equals 3x minus 5. Take that 3, 5 and someplace else. And I just don't like doing that. All right, so this section has some word problems. I'm going to do the ones that don't have word problems first. And so that we can get the hang of it, and then I'll go back to the word problems. So I've got a 6x plus a 2y is 2, and then a 3x plus a 7y is 25. So these are both linear. Your biggest exponent is a 1. And way back when, in January, I told you that these actually, you could write standard form of an equation. These are in standard form. We like standard form. So we got an x column, a y column, equals, and then constants. Okay, so these are both in standard form. Now my mission is I want to work vertically and I want to kill either x's or y's. So if I look at this, well, if I just wanted to kill off x's, if this is positive 6, well, if I could somehow force this one to be in, then 6x's minus 6x's. So I would kill off my x's. So how could I change that 3 into a negative 6? I can multiply it by negative 2. Cracky thing over here. And I'm going to say I'm going to take negative times everything in row 2. Okay? So negative 2 times everything in that second row. So here I go. Oh, by the way, this curly bracket means it's a package deal. So I've got 6x's plus 2y's is 2. And then a negative 2 times this is negative 6. Negative 2 times this is negative 14, and negative 2 times this is negative 50. Okay, and now look at this magic. When we work vertically, 6x's minus 6x's is no x's. 2y's minus 14y's is a negative 12y. Minus 50 is a negative 48. And so if we divide both sides by negative 12, we find out that y is 4. Okay, you found a y coordinate. That means this has to be consistent, and that means that this thing works. Okay, so I can make this thing work. So if I know what y is, I can go back of these equations and substitute it in and find out what x is, because they share the same point. So I don't care which one you grab, I'm going to grab the top one. So I've got 6x's plus 2 times the 4 that I just found equals 2. Well, 2 times 4 is 8. So if I subtract 8 from both sides, I get 2 minus 8 is negative 6. Divide both sides by 6, and I get x is negative 1. So this is a consistent system. And if I were to graph these two lines, they would share the point negative 1, 4. Okay, so it's important to know, because if you look at these instructions, it says use the method of substitution. I didn't want to use substitution. I don't know what method you're using as long as you use the correct method. So I choose to use elimination. So on this one, number 5, it says to use substitution. I'm not going to. I'm going to use elimination. So I have negative x minus 4y. We'll get to substitution in a second, by the way. Because there are times where it's set up really pretty to do it. It's just these aren't. All right, so I want to choose. Do I want to kill x's or y's? Well, this is a negative 2. If I can make this a positive 2, then working vertically, positive 2x's minus 2x's would be no x's. So let's go ahead, and how do I change this negative 1 into a positive 2? I multiply by a negative 2 through row 1. So negative 1 times, or negative 1x times negative 2 is 2x's. And then I'll have plus 8y's equal negative, and then this one stays the same. Minus 8y's is 19. So now work vertically. Is no x's. 8y's minus 8y's is no y's. So I have a 0. On the right, negative 18 plus 19 is 1. Does 0 ever equal 1? No, it doesn't. So this is inconsistent. These two lines happen to be parallel. Okay, so if you were to graph them on the same coordinate plane, they would never touch because they don't share a point at all. So when you click the answer box in Hawks, that's going to say inconsistent, and then this little symbol will pop up. That means that there's no answer. All right, so let's do a couple more. We have, I'm trying to squoosh all of this in one video. We've got negative 6x's minus 4y's is a negative 28, and then x plus 6y is 10. And again, I choose to kill x's. So this is a negative 6. I need him to be a positive 6. So I'm going to multiply through by positive 6 on row 2. And then when I do that, what am I going to get? My top row is going to stay the same. So I got a negative 6x minus 4y is a negative 28. This becomes 6x's plus 36y's is 60. And now working vertically, my x's are gone. 36y's minus 4y's is 32y's. 60 minus 28 is 32, so I find out by dividing both sides by 32 that y must be 1. So I got a y coordinate. It works. I know that this is a consistent system. I think the bottom row is easier to manipulate, so I'm going to substitute that y value into the bottom row. It doesn't matter which one you use because they share the point. And so x plus 6y, which is 1, equals 10. So if I subtract 6 from both sides, I find out that x is 4. So this is consistent, and I share the point 4, comma 1 with both coordinate or with both lines. Okay. I'm going to let you do number 7, and then I'm going to do the word problems real quick because I'm trying to keep this one to one video. Actually, who cares if we do 2 videos? All right, I'll make this one. I've got a negative 2x minus 3y is 21. And then 8x's plus 12y's is a negative 81. Okay, so there may be times where you have to multiply both. This is not one of those times. But you may have to like figure out, like if this was a 3, then I would have to make this a positive 12 and this a negative 12. You know, something like that. But it's okay because we don't have to do this. I'm going to multiply, this is a positive 8, so I'm going to make this a negative 8. So all I have to do is worry about multiplying by 4. So negative x's, and then minus 12y is 40, cats in here, sorry, 84. And then 8x's plus 12 is a negative 81. So again, it's 0 on the left, and I get a 3 on the right. Possible. So this is an inconsistent system. There are no solutions. They are parallel lines. Okay. So now what do? We are going to do some word problems. So this says, 2 angles are supplementary if the sum of their measures is 180. Okay, so I'm going to add the smaller angle plus the bigger angle, and I'm going to get 180. Okay, so smaller, bigger. Then it says, find two supplementary angles so that the larger angle is 136 degrees more than 3 times the smaller. So the larger angle needs to be 136 degrees more than 3 times the smaller angle. Okay, make sure I wrote the numbers right. Yes, I did. All right, therefore, this one is already set up for substitution because I know what B is. It's ugly, but I know what B is. So I'm going to take this value for B and shove it in the top equation. So instead of S plus B is 180, I'm going to put 136 plus 3S. So I have S plus B is 180. So on the left, I've got 4 S's, and then I'm going to subtract 136, and that gives me 44. Divide both sides by 4, and my smaller angle is 11. Okay? Well, they need to add up to 180. So if the smaller angle is 11, then what plus 11 will give me 180? That means my bigger angle must be 169. Okay, so my smaller angle is 11. My bigger angle is 169. You've got a complementary one. There's one about alcohol solution. So it says I have 32 ounces of one solution and 38 ounces of another solution. Okay, so 32 ounces, 38 ounces of this solution and that solution needs to be 60 ounces of a 37% solution. So 37% of ounce. So if you'll notice, we've got percent ounce times percent ounce equals percent ounce. And then I know if I add up all of the ounces to get 60. Okay, so this is just ounces plus ounces is 60. So you can either use substitution or you can use elimination. I'm going to multiply through by a negative 32 on this bottom row. So that's negative 32 and that's negative 32. And now my x's are gone. So 38y's minus 32y's is 6y's. And then 37 minus 32 is 5 times 60 is 300. So I get y equals 50. So if I have 50 ounces of this one, well, I need to add it together with this one to get 60. So if y is 50, then the smaller one must be 10. Because 10 ounces and 50 ounces is 60 ounces. Okay? And then the last one, you've got one about complementary angles. And I'm not going to have time to work this one out, but I'll set it up for you. We've got general admission and reserved seats. So for general admission, I've got $5 per ticket for general, and I've got $7 per ticket for reserved, and I ended up collecting $6,274. Well, all of the generals plus all of the reserves gives me $1,108. So this is about a baseball game, and actually I can finish this really quick. So I'm going to multiply through by negative 5, and then this is negative 5. I don't know what that is yet. So this goes to 0. This says 2 R's is, and then I've got 6274 minus, 5 times 1108 gives me 734. And then divide both sides by 2, and we're going to get 367. So the reserve tickets are 367. Okay, well, if my reserve tickets and my general tickets added up to 1108, I already know that the reserved was 367. So 1108 minus 367 will tell me how many generals I've got. So that gives me 741. So I have 741 general admission tickets. And then, like I said, the last one is complementary angles, so it's very similar to this one. They just add it to 90 instead. So that is 8.1.